Hello, my name is Stephanie Rawls, and today I'm going to be presenting my findings from Lab 1. In Lab 1, we charged pieces of tape by forcibly breaking contact between another piece of tape. The main goal of Lab 1 was to calculate the charge transfer between the two pieces of tape. The fundamental principles in this lab were the examination of charge properties, for example, opposites attract, and the conservation of charge, in which we see that charge only transferred, it is not created nor destroyed. And last, the importance of this lab is that it is very applicable to the real world. Some examples is the creation of touch screens, safety measures, and many more. For calculations, we must set some boundaries. The measurements for our tape include the mass of it, which is 0.002 kilograms, the tape length, which was equal to 0.2 meters, and the separation distance between our two interacting U-tapes that we did in the experiment, which was equal to 0.0175 meters. The constants used in this mathematical basis is that the gravitational constant was equal to 9.81 meters per second square. The electric constant is equal to 9 times 10 to the 9th Newton meters square per coulomb square. The electron-proton charge magnitude is equal to 1.6 times 10 to the negative 19th. Some useful equations include the net force, which is equal to the electric force minus the gravitational force. The electric field can be calculated by multiplying the electric constant times the charge divided by the separation distance between the two interacting particles. And last, our electric force can be calculated by multiplying the charge of the tape times the electric field that we previously calculated. Before we can reach our goal, we must establish the type of charge our U-tape has. We did this with a series of interactions. In interaction 1, between the tape and my hand, we saw attraction. Between tape and another piece of tape, we saw repulsion when they experienced the same charge transfer. Between tape and notebook, which is a neutral object, we saw attraction. And last, between tape and a negatively charged pen, we saw attraction. From these observations, we can conclude that the U-tape is positively charged. The reason why is that, of course, my hand is negative because I have salt on my hand, so that is a negative ion, which attracts a positive, which is the tape. And then also, we can look at the electric field equation for a negative charged pen. Negative charge is positive. If the pen was positive, we would have saw repulsion. On to calculations. First, let's establish some assumptions. 1. We ignore air resistance. 2. We assume that charge was evenly distributed amongst the tape. 3. We modeled the tape as a point charge. And 4. We assumed that acceleration was equal to 0. Due to our acceleration being 0, we know that F net will equal 0. The equation that we presented earlier can be manipulated where F electric and F gravity can be set equal to each other. Next, to find charge, we can manipulate our found equation to isolate the charge variable, as presented on the left side of the slide. We find that the charge is equal to 8.1 times 10 to the negative 9th coulombs. From there, we can calculate the number of protons with the given equation that is right on the left side as well, in which we find that the number of protons equal 5.107 times 10 to the 10th. Presented here is my computational model. Some important parts of my code is 1. The region in which we found our charge by using the manipulated equation described before. 2. The creation of my model, where I zip the visual diagram that shows our positive electric force, which is in orange, and the negative gravitational force in cyan. Last, we see the model found a similar number for the number of charge and for the number of electrons as seen in the print window highlighted below. To close my presentation, I will present 2 questions and their answers. Our what if basically asks, what if electrons and the protons exchange properties? What would change? I would say nothing much. We must see that the proton and electron are pretty much the exact same thing, except that the particles have a sign change. In this case, another sign change would not affect the properties of charge. For the why question, it asks, why do we need to minimize interaction with the tape? My answer is that you do not want to neutralize the charged material. The more you interact with the material, the more charge transfer. And from that, you can lead to balancing between protons and electrons, which will equal a neutral material that will not be affected by other charges. To conclude, this experiment exemplifies how charges behave when interacting with other charges, in which we witness repulsion between like charges, attraction between opposite and neutral charges. This concludes this presentation. Thank you for watching.